In the name of God, hi dear friends. In this tutorial we will study how to integrate IBM MQ and Oracle database using Oracle Data Integrator in 8 steps. Step 1, configure IBM MQ objects. Step 2, define binding file. Step 3, copy IBM MQ Oracle jar files to ODI. Step 4, define Oracle table. Step 5, configure ODI topology. Step 6, configure ODI models. Step 7, define project to receive messages. Step 8, send message to IBM MQ. To prepare IBM MQ for the next steps, we will first create a queue manager called QMGR during the queue manager creation. We will also create a listener on port 1414, which will be used to connect to IBM MQ in the next steps. Then we will create a server connection channel called channel 1. Then a queue called Q1 will be created at the end of this step. Finally, the queue manager code page, or CCSID, will be changed to 1208. That means UTF-8. For training purposes, we will use IBM Explorer to define objects, while we could also do this with a script file and the runs command. Right-click on the queue manager's folder and select the new option. Enter QMGR as the queue manager name. In this page, by selecting the Create Listener configured for TCP/IP option, we create a port for connection. As you can see, the port number is 1414, which will be used in the next steps. Now we need a channel connection server. To do this, right-click on the Channels folder and select the Channel Connection Server option from the new menu. We enter the name of the channel 1 and press the Finish button. We also need a local queue. After right-clicking on the Queues folder, we select the Local Queue menu from the new menu. Enter Q1 for queue name and select Persistent as the default persistence option. By selecting the Listeners folder, you can find out the port number to connect to MQ at any time, which as you can see is 1414. To send a message in correct character set, it is necessary to set the correct CCSID value of the queue manager, which, as you can see, is 437. But the desired value is UTF-8, which is equivalent to 1208. To change the CCSID, we use the runmqsc command. In the command window, we execute the runmqsc QMGR command, where QMGR is the name of our queue manager. Then we change the CCSID value with the command alter QMGR CCSID 1208. In order to connect to MQ, we will need a user, which we will first create under the name of MQ user in the operating system and give necessary grants to this user to connect to MQ. The link of these steps from the IBM website is placed in the description section. This user must have get put browse inquiry permission on the Q1. Then we give connect and inquiry grants on the queue manager to him, and finally connecting to the channel 1 from the localhost will be granted. This section has been prepared based on the instructions of this page. Some changes is required at the time of granting permission for Q. We need extra inquiry and browse permissions, and for granting Q manager permission, inquiry permission has been added to the command. For this step, a folder called JMS will be created in which the .bindings file will be created later in it. That file contains information about connecting to MQ server. To create a file, there is a folder called Java and a bin in it in the place where the IBM MQ software is installed, which contains jmsadmin.bat file. Before running batch file, the jmsadmin.config file must be edited and the appropriate driver and folder name for storing the .bindings file must be set in it. I want to create a directory called JMS in C drive. Now there is a time when we have to specify the JMS driver and the storage location of its settings in the jmsadmin.config file. Remove one of the lines of initial context factory and provider URL from the comment like in the movie, and after editing, we will save the file. Now we run jmsadmin.bat and run the necessary commands to define the Q connection factory and Q name in the command line. These commands are placed in the description section. With these commands, you will create a queue connection factory called SAMPLEQCF, which will be connected to an MQ server at localhost address with port 1414, whose queue manager name is QMGR and its channel name is channel 1. You also define a queue called SAMPLEQUEUE, whose real name is Q1 on the server. By executing the display ctx command, the contents of the bindings file will be displayed. In this step, we prepare ODI to connect to IBM MQ and Oracle database. The drivers of these two software should be copied in the userlib folder belonging to ODI. These drivers are jar files that are located in the java /lib folder in the IBM MQ installation location and also in the jdbc/lib folder in the Oracle installation location. In my computer, MQ software is installed in IBM MQ folder, so the path of my jar files should be IBM MQ Java lib. The jar files should be copied in the ODI's userlib folder. The names of the files are given in the description section. Its default folder will be app data roaming ODI in user home directory. You can copy the com.ibm.mq.allclient.jar file instead of copying several files. We also need the Oracle JDBC driver, which you can find it in Oracle's dbhome JDBC lib folder. Its name depends on the version of your Oracle, and in our case, its name is jdbc8.jar. This file, like the previous jar files, must be copied in ODI's userlib folder. The script files related to creating the Oracle table are placed in the description section. For the topology settings of the ETL process, we must create a new data server under the JMS queue node and create a physical and logical schema for it. In the jndi driver field, we enter the name of the same driver that we specified in the jmsadmin.config file. Also, in the jndi URL, you enter the location of bindings file. In the jndi resource field, the queue connection factory name entered in the bindings file creation step should be used. These steps are repeated for the Oracle database. You create a new data server under the Oracle node in the topology tree and create a physical and logical schema for it. After selecting the JMSQ node in the physical architecture tree, we create a new data server under it. We can use jmsadmin.config file to fill jndi parameters. This file can be found in Java bin folder of the MQ installation location. We copy and paste the driver name from that file. Also, when we want to fill jndi URL, we use file // prefix and path of bindings file, as you can see. Finally, we fill the resource name by QConnection factory name in bindings file. Next, we create a new schema for the new data server, and after creating the logical server in the logical architecture tree, we connect it to its physical equivalent in the global context. We repeat these steps to create a new data server for the Oracle database. At this stage, the models related to Q and Oracle table are defined in the models tree in ODI. Two new JMSQ and Oracle data stores will be created. In each of them, the definition of the object is specified. Since ODI treats Q like a simple file, its definition is like the definition of a plain text table. In the resource name section, we must enter the same name that we entered in the step of creating the bindings file for the Q. This table has a column equal to the largest size of the string message we receive. We select the Models panel in the Designer tab. We build two data model for Oracle Database and MQ. In the case of Oracle, with reverse engineering, the required data store will be built by ODI. After creating a model for JMSQ, we need to create a data store for the queue. Resource name property should be filled by queue name in bindings file. Remember that JMS.jdbc driver treats queue like a simple file. Therefore, for storing messages, one column as large as the largest received message is sufficient. So we define a string column up to 2000 character length. For the next two steps, a transfer project will be created in the project section, which for simplicity we create only two interfaces to transfer data from the queue to the Oracle table and transfer data from the Oracle table to the queue in the next step. To start, we must import the related knowledge modules in the project. In the first part, the source queue and the destination Oracle are placed in interface. In the flow definition, the module lkm.jms to SQL is used, and the for next part of video the IBM SQL to JMS append module is used to transfer data from Oracle to queue. The important point in next part of video is changing staging place of transferring Oracle to the queue data. We should select the staging area different from target option and set Oracle as the staging area. In the Projects panel, after creating a project to receive messages from MQ and store it in the Oracle database, we import the necessary knowledge modules before doing anything. We need CKM Oracle, IKM SQL Control Append and LKM JMS to SQL modules to receive messages from MQ. Now we want to create an interface to receive the message. In this interface, the source part will be the queue and the destination part will be Oracle table. In order to investigate the problems of character conversion in the next video, we have used two columns with different types. We use LKM JMS to SQL module for the load phase, IKM SQL Control Append for the integration phase, and CKM Oracle module for control. To test, I put a message on the queue and then run the interface. As you can see, if all the previous steps are done correctly and no error occurs, we should see the message inside the Oracle table. I invite you to watch the next video on the topic of troubleshooting this process to learn about control and solving possible problems. We need a new knowledge module called IKM-SQL to JMS append to send messages to MQ. To send a message, the source part will be the Oracle table and the destination part will be the queue. An important and key point is that we place the staging location in the Oracle database. Therefore, we do not need the load module and we only need to use the IKM-SQL to JMS append module for the integration phase.